students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we will be doing this chapter called as semiconductors. Let's see the numericals of semiconductors. Find the current through the following circuits. Find the current through the following circuits. This is your first circuit and your second circuit is these are your two circuits. This is a 2-volt battery and this is a 2 ohm resistance. 2-volt battery and 2 ohm resistance. Right? Now, let's see for the first circuit. I can say for the first circuit, let's assume this is diode D1, this is diode D2. D1 and D2. In the first circuit, both D1 and D2 are forward biased. You can see that the P-type region is connected to the positive terminal of the battery. That means both the diodes are forward biased. Hence, their resistance will ideally be 0. Hence, the current in the circuit will be nothing but V by R, which is nothing but 2 by 2, which is 1 amp. Now, for the second circuit, I can say diode D2 is reverse biased. D2 is reverse biased, right? Hence, it offers infinite resistance. Therefore, the current in the circuit is 0. Current in the circuit is 0. Fine. Next, let's see another sum, guys. This is diode D1, D2, 10 ohms. This is again 10 ohms. Right? And this is 5 volt. They've said that find the current find the current in the circuit. Find the current in the circuit. You have to find the current in the circuit. I can say that in the above circuit, D1 is forward biased and D2 is reverse biased. Right? D1 is forward biased and D2 is reverse biased. Hence, D1 offers 0 resistance, whereas D2 offers infinite resistance. Therefore, D1 offers 0 resistance and D2 offers infinite resistance. D1 offers zero resistance and D2 offers infinite resistance, hence no current will flow through the D2 path, hence no current flows through D2. Therefore the current in the circuit is going to be V by R. V is 5, R is 10. That's your resistance in the D1 circuit. That's 0.5 amps. Fine. Next, this is say 100 ohms, and they've given you that EMF is 3 volts. They've also given you that the barrier potential is 0.7 volts. Barrier potential is 0.7 volts. You have to find out the current in the current developed in the circuit. Find current. Right? Now, the EMF is given to you as 3 volts, right? Barrier potential is given to you as 0.3, 0.7. So, potential drop across the diode is 0.7 volts. Therefore, I can say that the potential difference in the circuit is going to be EMF minus the potential drop across the diode, which is nothing but 3 minus 0.7, that is 2.2 volts. So that is the potential drop across the external resistance is going to be 2.2 volts.
So 2.3.
2.3 volts. Therefore, I can say that the current in the circuit is nothing but V by R. V is 2.3, R 100, 0.023 amps. That will be the current that will be developed in the circuit. Right? Next, let's see another sum. R D E. Now they've given you that the diode has a constant voltage drop. Voltage drop across the diode is 0.5 volts. At all current, the maximum power rating, they've given you that power rating is 100 milliwatts. They also said that what should be the value of the resistance connected in series to obtain maximum current. Find R for max current. Right? And they've given you that EMF is 1.5 volt. Now, if EMF is 1.5 volt, then I can say that the potential difference is EMF minus the potential drop across the diode, that's 1.5 minus 0.5, that's 1 volt, right? Moreover, they've given you that the power rating is 1 milliwatt. Power is, 100 milliwatts, right? 100 milliwatts, that's going to be nothing but 100 into 10 raised to minus 3 watts. Now, therefore, I can say that the maximum current that can flow through the diode, is nothing but power of the diode divided by the potential drop of the diode, because P is VI, So Vi upon V will give you the current, that will give you your max current, that's 0.1 upon 0.5, right, which is 1 upon 5, that's 0.2 amps, that's my max current. Once I know my max current, then I can find out the resistance. Resistance is nothing but V upon I, right? Potential drop across the external resistance is 1 volt, current is 0.2 amps, which is going to be 5 ohms. Hence, a resistance of 5 ohms should be connected so as to have maximum current flowing through the circuit. Fine, do we get this thing clear? You found out the potential drop across the external resistance. You found out the maximum current that can flow through the diode. Maximum current flowing through the diode is power of the diode divided by the potential drop across the diode. So that gives you the maximum current. Now that's the current that is going to come out from the diode. That's the same current that will flow through the external resistance. So the current flowing through the external resistance is going to be 0.2. I know the potential drop, so I should be able to find out the resistance. Next, EMF E, current I, resistance R, Zener current IZ, Zener voltage VZ, load resistance RL, load current IL. Okay. Now let's see what all have they given you. They've given you that the Zener voltage is 6 volts. Load resistance is 1000 ohms. Series resistance is 100 ohms. EMF is 9 volts. You have to find out the value of the current through the series resistance, Zener diode and load resistance, and you have to find out the power dissipated in the Zener diode. Let's see this. Now, we know that EMF is 9 volt, out of which 6 volts is the potential drop across the Zener diode. Therefore, what will be the potential drop across the series resistor? The potential drop across series resistor is going to be nothing but E minus Vz. Guys, see this total potential supplied is 9 volts, out of which 6 volts is being used by the Zener diode. That means how much will be used by the external resistance? 3 volts, right? That is my potential drop across the external resistance. If I know the potential drop across the external resistance, I can find out the current flowing through the external resistance. Therefore, I can say current flowing through external resistance I will be nothing but V upon R. Potential drop is 3 volts. External resistance is given to you as 100 ohms. So that's going to be 0.03 amps. So the current I is going to be 0.03 amps. Once I know this, I can also find out the current flowing through the load resistance. Now, since the Zener diode and the load resistance are in parallel, therefore they will have same potential difference. Since Zener and load resistance are in parallel, therefore they will have the same potential drop. Therefore, I can find out the current flowing through the load resistance. Current is nothing but potential divided by resistance. Potential is the same as the Zener potential. Zener potential is 6 volts. Load resistance is 1000 amps. So 0.006 amps. Right? That will be my load current. Once I know load current, I can find out Zener current. I can say, but current is nothing but Zener current plus load current, right? Current in the external circuit 0.03 is Zener current plus 0.006. Hence, I will come to know the Zener current. Zener current is going to be 0.024 amps. Once I know the current, then I can find out the power in the Zener. Power dissipated by Zener is potential difference into current. Potential difference is 6. Current is 0.024. So this is going to be 0.144 watts. That will be the power that will be dissipated by the Zener. Fine. Next, take down next one please. Take down please. In a common emitter amplifier, a change of 27 microamps, in the base current produces a change of 65 milliamps in the collector current. Find beta AC. Find beta AC. Now I can say that beta AC, that's your amplification factor to the AC current, is nothing but the change in collector current upon the change in base current. The values are given to you, you can substitute and get the answer. The answer for this should be 24.1. Next, take down next one please. In a common emitter amplifier, the input resistance is 0.5 kilo ohms and the output resistance is 45 kilo ohms. If beta is 65, if the amplification factor is 65, find the voltage gain and the power gain. 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 Voltage gain is nothing but beta into R out upon R in. Voltage gain is nothing but amplification factor multiplied by output resistance divided by input resistance, and power gain is nothing but voltage gain into amplification factor. Simple straightforward multiplication. You should be able to do this. AV should come out to, voltage gain should come out to 5850 and my power gain should come out to 3.803 into 10 raised to 5. No units because it's just a ratio. Next, take down next one please. In a silicon transistor, in a silicon transistor, the base current changes by 20 microamps. The base current changes by 20 microamps. This results in a change of 0.02 volts in the base emitter voltage and a change of 2 milliamps in the collector current. Find the input resistance beta AC if the load resistance is 5 kilo ohms. If the load resistance is 5 kilo ohms, find the voltage gain and the power gain. Find the voltage gain and the power gain. Right, Ohm's law. Input resistance will be the change in the base emitter voltage upon the change in the base current. That will give you your input resistance. Next, beta AC. Right, amplification factor is nothing but the change in the collector current to the change in the base current. Right, voltage gain is nothing but beta AC R out upon R in. Beta you've already found out, so you should be able to get this answer. Finally, power gain is nothing but voltage gain into amplification factor. Right? The answers that you should get is input resistance should be 1000 ohms. Amplification factor is 100. Voltage gain is 500 and power gain is 50,000. Fine. Next, take down next one please. In a common emitter amplifier, an increase of 50 milliamps
Can you repeat the question?
in a common emitter amplifier, an increase of 50 milliamps in the base current, causes an increase of 1 milliamp an increase of 1 milliamp in the collector current. Causes an increase of 1 milliamp in the collector current. Causes an increase of 1 milliamp in the collector current. Just make that correction, guys. I'll just repeat that. In a common emitter amplifier, an increase of 50 microamps in the base current. So not milliamps, that's microamps. An increase of 50 microamps in the base current causes an increase of 1 milliamp in the collector current. What is the current gain? What is the current gain? What will be the change in the emitter current? What will be the change in the emitter current? What will be the change in the emitter current? Right? Also find out the value of alpha. Now let's see this. First of all, I can say current gain is nothing but change in collector current upon change in base current. That will give you your current gain. Now this is a common emitter amplifier. That means the change in emitter current will be equal to the change in base current plus the change in the collector current. So from here I'll come to know my emitter current. They've asked me to find out alpha AC, amplification factor, which is nothing but beta AC upon 1 plus beta AC. You already know the value of beta AC, you should be able to get this answer, right? I can say that the answer for this beta is 20, emitter current is 1.05 milliamps, and alpha factor should be 0.9523. What is alpha factor when you represent amplification factor in terms of fraction? Because amplification factor beta in itself would be a very large number. So if I want to represent it in terms of fraction, then that is your alpha factor. That's again an amplification. The only thing is here it is represented in terms of fraction. Okay. Next, take down next one please. In a silicon transistor, a change of 7.89 milliamps, a change of 7.89 milliamps in the emitter current produces a change of 7.8 milliamps in the collector current. What is the change in the base current? What is the change in the base current required to produce? What is the change in the base current required to produce equivalent change in collector current? To produce equivalent change in collector current. to produce equivalent change in collector current. First, let's find out alpha AC. Alpha AC can be written as change in collector current upon change in emitter current. Right? Once I have alpha, I can find out beta. I can say beta AC is nothing but alpha AC upon 1 minus alpha AC. That will give you your current gain. Right? Once I know current gain, then I can say that current gain beta AC is nothing but change in collector current upon change in base current. Beta AC, I would have found out change in collector current is given to you, so you will come to know your change in base current. Answer for this sum should be change in base current is 89.94 microamps. Next, take down next sum please. Write truth table for the following circuit. A, B. Okay. Now guys, here this is your AND gate, this is OR gate. Okay. So let's make the truth table for this guys. Truth table. You have A, B. Let's call this as Y bar. Y bar is nothing but A and B. And then I want A, let's call this as Y. I want Y is nothing but A or Y bar, right? 0 0 1 1 0 1 0 1, and in that case this will be 0 0 0 1. Or I want an OR between A and Y bar. So 0 or 0 is 0, 0 or 0 is 0, 1 or 0 is 1, 1 or 0 is 1. So the truth table for this will be 0 0 1 1. Fine? Do we get this? Now I'm going to draw a couple of circuits for which I want you all to make the truth table on your own. Right? This was the first circuit. Second. OR gate, joined with an AND gate, right? A, B and 1. Right? The answer for this should be, when you solve this, you should get your answer as 0 0 1 1. That should be your output. Next. NAND gate, two inputs A and B, and you have an OR gate. Right? That's my output there. I don't have the output for this. I want you all to calculate on your own. Next, NOT gate, NOT gate, OR gate, right? A, B, and output is Y. AND gate, NOR gate, that's your jumper. Which goes into another NOR gate. Right. This is my input A, B, and this is my output Y. Fine. The answer for this sum should be 0, 1, 1, 0. The answer for the previous sum should be 1, 1, 1, 0. Right. This finishes this chapter. We'll stop this here for the day. Thank you very much.